Good morning. How's everyone doing today? Just gonna check some settings. As you can tell, I have music going on at the moment. Just making sure that's all happy. Is it happy? Okay. Good. We have music on Twitch. Let's check YouTube. Testing, testing. Testing one, testing two. Good. YouTube does not have the music. Wonderful. I think I have everything set up right. Happy day. I will close Safari and get on with it. Okay. Well, all the tests are working. The magical little test elves have done their thing. And we will be moving on to testing fetch database. This is an interesting one. We end up asking for a fetch database request, and we get back a fetch database response. Now, what are these things? I can hear you asking. Fetch database request gives a shard, a name, and the checksum, the version at which we want the database. All right. In the response, we get a stream of these. Yep. A stream. We'll have a page number, the page data, and the checksum for that page of data. I do not think we're storing that. Maybe we should store that. That would be one more DB lookup. Oh, and I did all of this setup this morning to get some music going, and I forgot to turn the music on. Or rather, I turned it back off. Okay, hopefully this audio thing works. Um, I even set up the docking with a delay and a little bit extra so that the voice will be clear. So if you don't want the music, listen, like watch us over on YouTube. Okay. Okay. Checksum. Where are we going to get the checksum? Where does that checksum start? Where do we get this? I think we have some checksum information in the data itself. So that's good, but we're adding another layer. This data here is just to make sure that when it was sent over the wire, everything is correct. And then once it's validated as correct and applied, then everything gets summed up. And the database checksum would be basically the sum of, not the sum, but of the rolling checksum of all page checksums. Okay. Yeah, we can do this. Fetch database request. Replicate. Those beautiful tests. Good. Fetch database request. Happy path. Now we have 3 databases set up automatically for us. They're in the system. This context type. Fetch. Database. So that's where our client is. Async function. Something. We'll take a mutable self and the database name. Get back a fetch database response and a tonic, not a tanic. I was trying to basically wrap these calls saying, oh, this is a fetch, right? But now we have this, it would be a repetitive fetch database. Let's keep the pattern for now. I don't like it, but it is what it is. I want the shard. I want the name. Oh, and we need the database. Add a specific checksum. Shard name, DB checksum. That is a U32. Oh, that's right. This is a streaming response. Hey, Nightshade dude. How am I doing this fine Christmas week? Oh, goodness. Happy to, have the week off work. Probably going to be cleaning up the shop. Got a lot of stuff to move around in there. Became quite the mess. Oh, you get to work today. Well, hang in there, buddy. Oh, now that I got you here, I see you're on Twitch. How's the audio? Is the ducking working appropriately? It is? Okay, good. That's good. I even added a sound delay along with the ducking so that it would detect when I'm speaking, start to lower the audio, and then the delayed audio would eventually arrive while the music was low, and then later come back out. I think the only risk at the moment is that the ducking releases, it starts to basically become louder and increase well, about 300 milliseconds earlier than it would have normally. Perfectly great. Okay. Streaming response. I do not like fetch database. That just feels so weird. Maybe a send request. Mm. And then we have these other little utilities. I like send because set, get, fetch. It's just that it doubles up here. And this is my test code. Why do we even care? Oh, because I like the way it reads. When it reads well, fetch, send fetch database. Send database info. That doesn't work. Oh, just request fetch database, request database info. Maybe. West. How does that look? We have request, set, create, debug keys. And I set this up in order to debug the problem we were having last stream. Worked out all right. It just iterates over the keys. Oh, and I learned about escape ASCII. So if you have a vec of U8s, you can just say, make it a string. Render this as ASCII, just with escaped bits in it. And that works out really well. I like it. Especially since we have nulls in our strings. Okay. Text is good. Request. Fetch database name, and checksum. We have a couple. We have oh no, we have happy. We'll request happy, but we do not know what the checksum is for happy. So let's get the database checksum for happy. We will need, do we have a, we do not store it. Okay, maybe we should. We look at create database. We go through, create some pages, whatnot. This is going to be using the what is it? The test code for creating databases that we had set up from the other crate data plane. So that got extracted out into a test lib that we're using here as well. Now the thing that I want from this though, I want to change the seed. We're just going to have fun and just go with my whim. U64. Because I don't like that each of these is exactly the same. Okay, that's going to break a couple things. Let's fix that. Ooh, let's get rid of that. Trying to be nice to my warnings as well. Unused by default. Oh, yep. That just goes away. Down to 20. All right. Create test DB. Now before, see this is in data archive. Before we needed them to be basically at a specific version or a seed. We're going to bubble that up. Break things elsewhere. Good. The default seed has been 42. But I think it really only matters in certain places. Hold on. I think this here, create database. This is for the 3DB test context. That's fine. Say this is 42. This is 1337. What is the last one? We need some something that's not insulting, you know. What else can we spell with the calculator? Oh, we could do hex. Dead beef. There we go. Oh, let's switch that with oh no. Oh no is dead beef. There we go. Very nice. Now our databases are not identical. Yay. And what do we have here? Ah, okay. Well, that's something else. This is in data plane where we had been before. Create server DB. Let's see. This is still 42. That's what it had been. I don't want to fix these tests today. Do coffee. I love it. We're going to replace leet with that. Not there. Hmm. What else could be spelled? We could replace 42 as well. See, this is the one thing we'll have to change. That checksum there. All right. Request fetch happy. Those. It's not a value. That's fine. Ooh, private interface. Yeah. Dead code. That one's okay. Is this also dead code? Okay. Some of these we're going to leave for now. Let's run the tests and we will see what the new value is. Oh, but yeah, I also broke that. Okay. I want to fix the test before we move on. Okay. It was 3647. Now it's this. Okay. And those should pass. Let's move on. Oh, except I just broke it by uncommenting the other code. All right. So at this point, we're going to fetch that. We'll await it. Unwrap it. Stream response is equal to that. We do not have a DB checksum. Very important to have a DB checksum. So let's figure out what that is. We have to have this somewhere. And let's see, when we are creating a database, create database. So in this function, we do collect this DB checks, this checksum DBs object. We happen to know what the checksum is at this point. I did notice that by adding all these databases getting created, it really does slow down the data, like the tests. They had been nearly instant, and now there's a pause. It makes it seem like there's so much more work being done. Okay, so my concern is that I'm going to have to maintain this DB checksums. I don't know that I really want to do that, but let's keep it around anyways. Let's add that to self. Take that, put it on this. Checks. Not fond of the name though. Checksum DBs checksum. Leave it for now. Great field. And the tempter path. Okay. It does not need to be mutable. Because we're using that concurrent DB. What was it? Dash map? Yeah, dash map. Okay. So at this point, let's get the current checksum for the happy DB. Then we could even make a change to it. TC dot checksum DBs dot get. I want just a easy to use interface. Database checksum. I want to use it like this. Create that for me. Oh, come on. You know you want to. Okay. Database checksum. Function. Database checksum takes a self, returns a U32 or result. So what if the database doesn't exist? Result to an option? Let's see. We'll start with the basics. And this is supporting test code, so we could panic, but I would prefer to return result or an option and then panic in the test code. But this isn't async. Self.checksumDB. Wait. Is this the wrong context? This is data plane. All right. Undo. Take. We'll put it above the debugging bit. There we go. So before, we had simply added a database to get the checksum. We want to get a database. Relative DB path. Oh, we need to pass the name. So we get the DB. Let's just return 0 for the moment. And this returns an option. I can map this to a result. I'm tired of typing dyn standard error error. I'd rather do a standard error. Oh, wow. Yeah. Got it. All right, database checksum. Here we are. Now, in this case, where we get nothing back, let's say get database returns an option to it. What are the functions on option that let you convert an option to an error? Let's say k or that would work. And what is the error? Doesn't exist. We can maybe do it like a standard IO error. New. Error kind not found. What was the second parameter to IO error? The error. And if we're doing string formatting, let's do OK or else so that we're not always doing this work. Did I put that at the wrong place, didn't I? One of those. Should have been a comma there. Another paren there. Maybe? This is going swimmingly. Okay, formatted. That means I got it close. Database checksum. Let's bail there. Now we have reference to the DB, and we can call db.checksum and return that. Okay. Now we have a checksum to send on. What is the name of this plugin for icons in terminal? Good question. Livio. Oh, this over here? Like these? I'm actually using the Z editor. But this here, the terminal is just using Unicode characters. So I think I'm using something like Starship, or I forget what my terminal setup is. Welcome. Is that Starship? Yeah, I think it's Starship. Let's see. Stream response. We're not doing anything with it. And what do we expect here? We expect something off that. Into inner. Is that a stream? What is this? Yeah, it's streaming. Fetch database response. Great. 4. Can we collect on that stream? This is more of a while at some. Stream dot what? Stream dot next? Let's guess how to wait. Okay, let's go look at what this is. This is a tonic streaming. So documentation. Streaming. Oh, it implements stream. I think I do want next. But I have to implement or pull this in. There we go. Is it not mutable? Yep. Okay, now we have data. Data is a result of a fetch database response, and we can start to collect this, I don't know, into something. Probably, let's see, I don't know, a vector, or we could check each page against the disk. What do we need to check? We need to make sure that we get every page, each page once. Ensure that the page data is correct. Okay. So we have our data here. Good. Let's collect this into something. Do we know how many pages we're supposed to get? We can know that. Would that be off of basically the same object here? Because I believe this guy knows the number of pages. Because in this, here in the DB object, has a vector of each, and with the checksum for each page. So if we lean on this, we could know. Otherwise, we use the file on disk. This is already calculated, so let's go ahead and use it. So here's context. Now, what do we want it to look like? We're building out a new API. Now, let's ensure the page data is correct. Data dot, What is data? Oh, it's a result. Hmm. Let's do a transpose with a toss on there. Okay. Now we just have the fetch database response, and we have our data. I need to refresh that page over there. Come on, Twitch, keep up. Oh, and thank you for the follow. Let's say Rosso and Livio, thank you for those follows. All right, so we have the page checksum that we got from the stream. We could check that against some information we get back here. Let's create an interface similar to this. We would have page checksum. Database checksum is equal to, no, we want database page checksum. We'll give it that and the page number, data.page number. Okay, that doesn't exist. Something like that. It's going to be a modification of this. Going a little deeper. And let's see, we get the checksum DBs, we get the DB. Got it. Sure. Error if it's not found. We have DB here. DB dot page checksum. We give it the page number. Very similar to the last one, except we just ask for the page number. Mm. Function. Checksum DB. We're creating a little utility here. Now that's what it's called. Basically, I want this dried up from both of those. What is this type? This is one of these. Hmm. Brat. Yeah, this type is leaking. Hmm. Given that it's only in the test code, I don't care as much. Let's see. Data archive. Argo. Much better. Method defined here. What are you talking about? Private module. I think it's exported one level higher. Is it not? Hmm. But does DBs have an interface for that? Add database, checksum, get DB. No. Hmm. Okay. I think this needs to be some sort of, I don't know, needs to be wrapped up in our own type. But that's not today. Oh, and thank you, Lava, for the follow. Thank you. I feel like I'm going to actually butcher your handle, but here, let's try it. Lava Mosa Muka. Thank you. Thank you for the follow. Check some DB from name. Yeah, that looks good. Replicate. So we have our page checksum. It's U32. Let's assert that the data's page checksum and our page checksum are the same. Oh, page number. Really? Yeah. Okay. Now, we need to know how many pages there were. This should be a unwrap. Okay. Now, how do we receive each page? We could put them in a set. Hmm. What else? Oh, we need to check the page data. Let's store it in a vector. With capacity. I don't know how big it's going to be. See, we don't want to. We'll resize. Data.page number. We'll have none. Okay. Now, once we have it, we've resized, made sure that the vector is long enough because these pages could come in any order. We could get the last one first. It could be the millionth page. So we have to resize the vector, and then we can put something in it. Pages, page number equals sum data.page data. Okay. Now it has all the type information it needs. Do we need that though? We just did the checksum. By checking the checksum, we know that it's correct. So maybe we just say we received this. And we put the page checksum in there. I don't know, something. That also gives us the number of pages that are not none. Hmm. Pages dot. Is there a count? Dot into iter dot count. That's how many. Dot. We could filter and then count. Predicate. As is some option. Dot count. We'll assert that page count is the same as we'll create something new on TC. TC dot database page count. So, wow, what did that do? Do I already have that on there? I do. Okay. Nice and easy. Let's see what happens. This should fail because we haven't actually changed um, the implementation at all. So here we return just empty. And 14 pages. Interesting. Okay, our happy path panicked. Let's just do the one. Good, much faster. Now, technically, I guess we could have hard coded the 14, but no need. Back to where we were. No. We have tests now. Now we need to make this work. Okay. So, how do we get all of the pages to send? We have some nodes. We thought through this a little bit already. Now, I did rename these, our namespaces. This is removed these portions because there was a bug. Okay. Now, we have the state, we have the info, we have the checksum, page, and page. You'll notice that the pages differ here. We'll have page number and transaction ID. Wait, is that how I ended? No, I have transaction ID and page data. Thank you. Thank you, past self. Oh, we store the page data? Hmm. I don't like that. I don't like that it's encoded in something else. I'd rather it just be the raw bytes. Maybe we stuff this? That's not doing anything. We have to do the fetch anyways. See, I was planning on using line 35, this here, as a method to search for a transaction ID. So basically, we don't know what the transaction ID is going to be for a checksum. Is that correct? Let me think through that again. Oh, we already did it. Client requests all DB pages for a DB. Look up the transaction ID for the database checksum. So we look up, what is this? Oh, I should update these as well. We have info. Little underscores are the nils. Should we state? This isn't quite right. Is it? Is that how we implemented it though? I think we implemented it by looking at state and info. We only need info. So we have our state keys, database info. Yeah, we can just scan on that. Oh, we need the state to know whether or not it's deleted. Of course. Okay. Which means for this, We need both. Scan for that and shard state yes, return left. Okay, that's more accurate. Client info. Now for info, do we need both? I think we do. Let's double check. Get database info. No, we just let's look here. Database info. We get both. Why do we get both? Here. Ah, we need the checksum. Okay. Yep. Just making sure the documentation is correct still. Client requests database info. Okay. Let's checksum the right key. Yep. Checksum. Look up the transaction ID for a database checksum. Okay. So we get the value of that. Let's make sure that's what we're actually doing. We have transaction ID. Okay. Set database page. There we go. Use the checksum key. We put data, the transaction ID. Transaction ID is the only thing for that. Okay. Yep. Transaction ID is the only piece of info. Great. Scan for the page that is equal to or less than the most recent transaction ID, starting by getting page 1, as it contains the total number of pages at that version. Oh, right. We were going to parse page 1's data, this information here, because page 1 includes the total number of pages in the database. All right, let's get through this. And I'm really looking forward to, once we've made it through here, let's see, where's our little monitor? So once we've gotten this piece done, we'll work on this piece, probably come back here, make sure the data is being applied correctly. I don't think it's actually right at the moment because we're not mutating wall logs and whatnot. Yeah. So we'll do this side over here. We'll come back over here and get this one updated. Once this is up and ready, man, I can't wait to build applications on top of this. Delete from users. Thank you for the follow. All right. Checksum. Scan for the page that okay, yes. Transaction ID. Scanning for blah. Then getting data from there. Page data. Okay. And what does this give us? So that gives us no. Oh, that tells us what the transaction ID is. So basically, we do a range search looking for a specific piece of data, and that data is part of the key. So we need to know. Wait, don't we know the transaction ID? No. Because not all pages are part of a transaction. So we know what the last transaction is going to be, but we don't know what the transaction before it is. Okay. So we'll have to kind of guess. And that's going to be more or less time-based. This transaction ID start with the 64-bit epoch and go from there. Okay. I really do wish that, where is it? The TiKV had a scan where we could scan for so many going backwards. Like I want to reverse scan. Wait, can this do that? Bound range? Because you can give it a limit. Can you just not have the starting bound? Is the minimum key empty key? So range may not be unbounded below. Yeah, but see, it's not going from the right side of the range, or from the end of the range coming back. I want a reverse range. I don't want all items in the range. Hmm. Now, this would only be used. This would only be used when a database is being downloaded, right? As everything is streaming, this isn't going to be used. So really, this is only going to be used when a new machine is coming online. So when a new machine comes online, hopefully we can just go back, 5 minutes. Just get all the pages, all the transactions for the given range for the page. And we just keep going back, expanding the time range until we get it. Okay. Yeah, I want to reverse scan. Kind of like sled. Sled has. Wait, does it have it? Nope. It just has range as well. If we scan keys, we get a vector of keys back. Okay. We can just scan through the vector backwards. What would be a good method of searching for these? Given the current transaction ID, we know that other pages that happened That basically the other pages that we need would be before the current transaction ID. So we know the end of the bound, excuse me, the end of the range, but we don't know what a reasonable guess is before that. I gotta change the music. How did we end up in this? No. Electro swing. I gotta try that again. All right. All right. So the beginning of the range. Back to that. What's it going to be? We know what a reasonable end is. Hmm. If the database is really busy, right, it's mutating all the time, then we could be getting tens of changes per second per page, or hundreds or thousands, right? I guess we maybe lean on limit, because we could very quickly kind of binary search. We make some guess, right, and say we want 5. And if we get nowhere close, right, if we get 5 and they're all very close together, then we could cut the range in half, or split it, then try again. But our smallest increment is going to be 1 second. So if something's really, really busy, it would be down to the second. And we could set the limit rather high. We could say, oh, we want 100 of these. Say we go back an hour. If it's not in the hour, we go back, we double it. We keep doubling it until we find it. Kind of a reverse binary search. Reverse binary search. That sounds so silly and doesn't really work. Okay. Back to the code. Well, we can toss some mud at the wall. Let's make sure these are correct. Okay, we have checksum. Let's go on page data. Okay, that's good. So we're looking at this at the moment. Look up the transaction ID for the database checksum. Let's do that. You know what? Let's just copy this. At fetch database. Here it is. Oh, Does it need to be a channel? Can it not be an unbounded channel? Oh, it can. I'm sure it can. Sender receiver. Hmm. Why is this even a stream? Because the database might be massive. Because the database might be massive. That's why. All right, let's change this to be unbounded. Unbounded channel. There is no limit. Unbounded receiver stream. Self. Expected receiver stream result found. Unbounded receiver stream. What? Message T. Okay, that could be unbounded. Who has decided? Response. This is generated code. It's something that implements the Tokyo stream trait. Where is it getting that type restriction? Oh, here. Unbounded. Okay. That works. So I think we're actually going to pass the sender information into the lib function and have it do all the work. I don't think I really want to have this function here doing a ton of work, and we can even kind of bolster our test code in the lib crate. So self dot fetch database. Why not? And what information do we have off of the request? Fetch database request gives shard name and DB checksum. You know what? Let's break that down. Let fetch database request equals request. Really? What did I do? Go back. Shard name DB checksum. Probably be async. What if the database doesn't exist? Yeah, that Oh, no, we want self.archive dot blah. Okay, that doesn't exist. Good. Now, if it doesn't exist, we'll want to return some sort of error here. But we'll have to map the error. So we'll need to validate a portion of it, like maybe the first portion, saying like, hey, this checksum exists. I think in data plane, we even wrote tests against that. Let's see, what did we do in data plane? I want to um, make sure we handled that. It would have been in DB. It's in here somewhere. Test that a DB is added to the sequence. Okay, no. Skip if they're identical. Here we go. Out of range and not found. I think it's technically out of range. Same database with slightly different state, or with the client slightly out of date. When the client tries to stream the changes, the server will return an out of range error. Okay. So we're expected to return out of range if the checksum is not found. Could not find the checksum for the, yeah, okay. So if we can't find the checksum, but the database exists, we give out of range. What else? Then here, if the database isn't found, we say it's not found, right? Anything else? Test to be sync if there are changes. That one's different. All right. I think we've answered the questions. Let's put this up. Some notes for future self. Those first two errors would come directly from this and wouldn't be part of the spawned off task. I don't see. Part of me wants to split this up to two different pieces. Because we're using an MPSC, we could kick off tasks that look for each one of the pages. The challenge, though, is we have to look up page 1 to know how many pages there are. I think we're going to change this. I don't like that. This piece right here. I think we should store that in database info. This database info right now just has page size. You know, we could do it in state, because state changes all the time and the number of pages can change very frequently. So for this transaction ID, we would also have page number or number of pages. Page count? What does SQLite have for that? No, we want SQLite wall log format. Same. For each of the wall index header details, you get the database page size and the number of pages in the database. Wall index header divisions. So you get these 136 bytes for every wall log entry. And that's what we'll have end page. Page count, number of pages. They have end page. I don't want that. Number of pages. Sure. Okay. Let's change that object that we're serializing and fix that. Oh, that's not going to help us. We need it here. So we get the transaction ID. We want it there. Because it's the number of pages at a specific checksum. So we need the transaction ID and the number of pages. Then this works. That will work for us. Oh, and James, thank you for the follow. Let's update this. Let's update that. That would make it so much faster. Then we can just kick off n number of tasks each one, the MPSC sender going and scanning for the given page. When they find it, they send it, drop the sender, and when all the senders are done sending, they drop and it closes. It knows that it's done. Oh, I like that. Okay. Transaction ID. Let's go back to lib. Set database page. This here. This is going to be wrong now. So when we set a database page, we need to know the page and how many pages there are. Good, that'll break all the code. And we need some object here instead of this. Let's go to our types. What do we want to call this? This is the checksum state. Has transaction ID and page number. Database something. Like checksum. This isn't a checksum. This is the data that you receive if you give it a checksum. Searching for a name. Transaction ID and number of pages. What do we do with this data? This kicks off. This is the database download info. It's a gross name, but we can rename it later. So we want to put inside of there, database download. We need to serialize first. We want the transaction ID, and database page count. This is the wrong one. I should be doing this one. These should never fail to serialize. Okay. Page data. It's called page data now. Okay, checksum. Just make sure we're looking at the right one. Database checksum, readme, checksum. Good. Now back to lib. We're setting the database page, right? But we don't really have a get database page, right? So that's okay. We're just setting all the information that needs to be saved. We save it all at once. Right? We build up some futures, then we pull the futures together using a try join. So hopefully, hopefully there's many tasks that can start interacting with the database all at once, because there will be, some database requests sent out over the wire, because this is, Tokyo. Who knows? Maybe it would happen at the same time, depending on the machine and the number of threads. Okay. So we have our try join, all of that. And luckily, nobody ever reads this data, so I think that's the only place that needed a change. Though we have 3 errors from our previous issue. Where is it? Error. Ah, no method named fetch database. Is that it? No, there's 3 errors. Where are the other ones? Ah, in context. Yes. RDB chunks. We need to know how many there are. Extract into variable. Thank you. Chunks. Chunks is an iterator. Actually, let's pull the whole thing out. Extract into variable. Let's rename that. What do we have here? Page info, whatever. Exact remaining length. The implementation ensures that the iterator will return exactly length more times. I think I need to collect. Page info. Oh, it needs to be a vector. Don't care. Now we have the total database pages. And that's DB page, then, then total. That's iffy. Okay. And we have yet to implement this. Good. Let's split this. So we look up transaction ID and total DB pages. And so I did this in two phases. First phase, and then the second phase. I'm still sorry, I'm just reeling by this name in the types. Where did types go? Replicate we're working on. That goes away. Database download. Like, it's like database at checksum info. Oh, that's so gross. Database at checksum info. Gross. But it's better. It is better. Because now we could say self.archive.get database info at checksum. Although the name is kind of whatever. Okay. We're going to await dot, and then we'll have to map the error, etc. Okay. All right, so what information do we need? We need the shard, the database name, and the checksum. Shard. Let's move this down. Name and DB checksum. Hey, Lukey. Oh, sorry, I misread that. Limit code, how are you? How are you doing? Async function that we want self. We want the shard. We want, sorry, lost my train. Shard name and checksum. Hold something with error. Okay. So basically, we just want to look up that one key. So what is the database key we're going to use? It is checksum. So we need our database checksum key. And for this, we want shard, DB name, and DB checksum. Shard, DB name, and DB checksum. Self.db.get. And we want that key, DB checksum key. We will map that error. Yeah, we'll do something there. Toss it, boom, done. Now, what do we want from our error type? Storage error? Sure. Storage error includes gets, puts, etc. Can I just do... Oh, you know what? We can do with here instead. With context. Storage snafu. Okay. So we have that. We have the information. Our value. Is it from bytes? Hmm. This info here. This is our new type, which is database at checksum info. Still don't like the name. Oh, I found an option. Oh, great. So if this doesn't exist, we will return none. At this point, we will map the error, or we'll map this. No, we definitely want to only deserialize it if it is one, if it's a sum. But no, we can't do that. Let's just match. Okay. Ah, finishing up wrapping gifts. Oh man, I did that yesterday. We've got a couple more to do. Now you can be lazy watching some Rust programming on Twitch. What about myself? Implementation is going well. Let me take a step back. So this is the stack that we're building, right? We've written a bunch of proxy code, written a bunch of VFS code, some data plane code. Actually, this side for the reader, not really so much for the writer. We're currently in the process of working on data archive. So the whole system is getting roughed out at the moment, which I like. I'm really looking forward to being able to connect all the pieces, but all the pieces are kind of big. So we're definitely doing a TDD kind of development style here, which I do favor. I really do like this because once it's up and running, it gives you so much more confidence and you can move so much more quickly. All right. Sorry, I was just looking up at, I have both stats going on for YouTube and Twitch. Because we're streaming to both. And I see that it got a like. I think that's the first time one of my live streams has gotten a like in forever, like in ever, forever. It's just didn't really realize it was a thing. I just saw the number one up there. It's kind of crazy. All right. So we have a storage snafu. We will return none if it does not exist, because that's not an error. Not yet, anyways. Not at this layer. Not at the library layer. Okay. Let's go back to replicate. Arguments are incorrect. What? Oh, you want references? Fine. And what is this error? This error would be, oh, if this bails, then it's some sort of internal error. Because that would be serialization or some sort of storage error. We could look at the actual type of error, but I don't think we need to. So in this case, we're going from our error type. Oh, are we logging? Hold on. I always want to log very loudly with these. Inspect error. Same here. So we will inspect either one, logging very loudly. Could not get database info at checksum. Error. Go toString on that. And then let's also put the key there. Key. db checksum key. That there will actually, because we implemented this trait, add a number of pieces, which should really, really help with the debugging. Okay. I'm surprised that it didn't format that. Okay. Inspect doesn't take anything back, does it? No. Okay. And log error, what does it return? Unit, hopefully. Could not deserialize value of, let's see, get database info at checksum could not deserialize value. We have our error. With the key. Key. There we go. I knew something was wrong. Okay. Oh, what is it? Error. Use of moved value here. Is this not clonable? Oh, it's got well, that's copyable. As there are references, we can copy it, which makes all of those issues go away. Okay. So now we're logging loudly. Yay. Good. Okay, okay, none. Back to where we were. In replicate. Nope, wrong one. Get database info. Oh, wrong one. This one here. Now at this point, we want to map these errors. Now that everything's been logged, we're going to be super noisy. We're going to log again, just so we know the full stack. Let's see, fetch database. But not blah. Error is, we have some toString going on there. Let's move on that. Oh, actually, okay, let's finish this up real quick. And anything else? Fetch database request, maybe? I think it'll be bubbled up. That should be all right. Log error. What am I missing? And we want to map this to a tonic status. This would be an internal. Because if we return none, that's the not found. Oh, actually, how do we know the difference between not found and out of range? Because it's part of the key. We not differentiate between the two? Because the checksum is part of it. We would have to do a second lookup to see if the database existed. I do want to be able to disambiguate between out of range and not found. I think we have to do a second lookup. Fascinating. I don't know that I like that. Like making two requests. How about if one fails, then we make a request in order to tell what the error is? Because we don't really need both requests for, hopefully, the common case, the happy path. So let's do fewer database hits and only do the second database lookup in order to disambiguate them. Okay. I convinced myself. Okay, we map this. Message. But what is message? Message is internal. There was an issue. how much information do we want to give the clients here? They just need to know that it's internal. Nobody should be parsing these messages. Basically, I'm going to search for this someday. I need it to be somewhat unique. All right, now for fetch database, this is just blah. Once we have this back, DB info at checksum, it's an option. Match DB info at checksum. If I do this differently, DB info at checksum is none, then we will return here. At this point, look to see if the DB exists or a not found. Otherwise, it is out of range. Otherwise, okay. Let's see, do we want info or state? It doesn't really matter. Oh, and what if it's deleted? I guess we could say that. That information would be in state. Shard DB name is name. Oh, what's our error going to be? Okay. At this point, if it doesn't exist, then we know. If state dot, well, let's match. See, we could if let sum, we could if is none, we could match, but we also have to handle the other case, which is it's out of range and it's deleted. Both of those. See, I don't want to nest. That's the thing. if let sum state equals state. Okay, and we can do an else on this, correct? Oh, we're still nesting. This is still a match. So if we received nothing back, we will return tonic status not found. Could not find. Let's see. Name. Okay. So in that case, not found is done. In this case, if we have something, then what do we do if it's deleted? It's like this, but we say this database has been deleted. What do we have for state? State is this is only if the checksum is done. Okay. It always feels like most servers, like most of the code is actually dealing with the unhappy path and erroring and conveying the state in case of error. So if it's not deleted, okay, now this is the one we were digging for. At this point, it's out of range. Now find checksum, db checksum. All right. Then we have the happy path. So this is the sad path. Let's say, no, forget it. I'm going to keep going for now. All right. So now that we know that we have this database, we want to kick off a bunch of tasks, some senders, along with this DB input checksum. Basically, we need to kick off a bunch of tasks for these different, for sending these different pages. For, I don't know, x in 0 dot dot. Oh, the pages are 1 based, so it's going to be 1. Page number in 0 dot dot. To the max. At this point, we know that not none. I want to unwrap that. Let's convert this into a match. No, not like that. Let db info at checksum equals match blah. db info at checksum. Where's our db? Sure, syntax error. Fill match arms. So we have a sum, a none value. We're just going to pass the value through. It's been unwrapped. In the case of none, we have this. And the if's gone. Okay. Where's our type? Oh, database at checksum. Okay. Really? Oh, DB info. Okay, transaction A, page count. Now, do this. No longer a dummy implementation, huh? All right. We need to do self.archive.find and send DB page. Now, the first piece is that there. Second piece is here. Can we break this into smaller pieces? Look for the transaction ID for the page, and then send the page. Now this is going to be search for closest page. I will want that. And then we find it here. Okay. Tokyo. Spawn. We give it a future. What sort of future shall it have? Async move blah. What happens if this fails? We get a join handle, but that's fine. I think it would look something like self. Oh no, we need archive, don't we? Can we clone archive? We must be able to clone archive. Archive DV. Okay, that is clonable. Is it a I think that's okay. we'll give it a clone of archive. We'll return that. So at this point, archive dot find most recent page to transaction. And we would need to give it the shard, database name, page number, and transaction ID. We would need to await that, etc. So we do that first. Then once we have the result from that, let's see, this would be most recent transaction ID. Let's say page transaction ID. Archive dot, and then this would just be a straight lookup. Archive dot get page data. That would be shard, DB name, transaction ID, and page number. Now this is page transaction ID and page number. And once we have that, we would have a clone of the channel, the sender here. At that point, we would do like some sort of sender.send. And what would we send? We send a fetch database stream. Fetch database response, I think. Do we need to await that? No. Okay. So page data and checksum come from here. Hmm. That page checksum, it still doesn't feel right being there. Because it could be here. And then we just have page data there. I'm going to leave it. This will be, I don't know, 4 kilobytes. I was hoping just to have, to not have to wrap the SQLite page in something else. It just seems like it would take longer to parse. Why not just parse something that's, less than 120 bytes and then just pass this through? I like the idea of having the page checksum. Okay, I think I want to change this. And this is just raw data because we could always look this one up if we know this information. Okay. Then we're not running a serializer over large amounts of data or a deserializer. Yay. Less work is always more efficient. That got updated. This needs to get updated. All right. I'm going to take maybe 10 minutes. Gotta get some water. Been doing this for 2.5 hours. So, back. Oh my goodness. In 10. That would be, let's say 13. It'll be like 10:10 PST. All right. Bump the font up there. Woo. So everybody can see it. All right. I'll be back. All right, so it looks like the music stopped when I walked out of range. Sorry about that. I did pick up some food though. So even though I have a couple minutes left on the timer, I can maybe chat a little. Got some yogurt, saw some pistachios in it, some golden raisins. This is what? It's very plain yogurt. It's like Greek yogurt. Oh, thank you. Thank you, Luki. Whoa. Too big. There we go. So now, due to that change, I'm gonna have to update some stuff. And I'm gonna be munching, so might be quiet. So by interesting. The change that I'm proposing means that we have to do two lookups here in the case that somebody wants a diff. I don't know which one is going to be more likely. I think we can optimize this one though, to also fetch this. Dog's barking. Be right back. Okay. Good, good. All right. So we would have to look up that and this. Okay. Mm. Would this be a key scan? Probably. And then we would iterate one at a time, fetching the database info. Because it's already allocated. I guess that would be fine. It just might be a lot of memory. If we use scan keys, then we don't use up as much memory, and we can stream the data out. Much more friendly on the system. Hmm. Okay, I like it. And we can request both of these at the same time. Smudge on the yogurt. So, I don't have to do all the talking. Anybody got any dad jokes? Clean dad jokes? I saw my little list of them the other day. It was fun. Trying to log into my OneNote. And a code? Goodness. They want all the things. Oh, they want it from the Authenticator app. So much effort to get to the list of jokes. All right. Oh, there we go. Found them. All right. A genie grants me 3 wishes. I ask to be rich. The genie then asks me, "What is your second wish, Rich?" But I don't guarantee that these are good, just that they're dad jokes. What is a dinosaur? With an extensive vocabulary. Thesaurus. Yeah, not everybody cringe at the same time, please. Thank you. Been a weird winter. Much warmer than usual here. How's everybody's snow load? You're also quiet today. We can have comfortable silences. Almost done with the yogurt. No, I'm about halfway. All right. Let's change the music. Want something else. All right, let's go fix this. Let's update the codes. We're updating the codes, the codes, the codes. Update the codes. All right, so we'll come back to this. But we broke some other things. What did we break? We broke this one. That now has a transaction ID. Well, no, it has data associated with it. Oh, you know what? Why don't we just call it like checksum data, transaction ID data, checksum key data. Oh, I like that better. Types. And this one was transaction ID. Page checksum. I think that's all it is. Let's go back to lib. Where do we use transaction key? Let's get a reference to all of our uses here and in DB keys. Okay. Must be here. Set database page. Ah, it's being set to nothing. Oh, interesting. Now we need the checksum for the page itself. Yeah, if you have the page, you should have the checksum. Hmm. I don't like that these are U32s right next to each other, representing the same kind of data, checksums. I want them kind of grouped. So this one is more of a page number. Page checksum, page number. Here we have page data. Page count. We're going to reorder these. Maybe transaction ID between the DB bits and the page bits. So we give it the shard, database name, checksum, and page count. Then for this transaction ID, you have this page checksum, page number, and page data. That seems reasonable. Which means that we need to serialize some more data. Oh, I'm going to take another bite of yogurt. Mmm, yogurt. Okay. That's okay, but we just broke a bunch of other stuff. Let's see. Tell us what is broken? Unclosed delimiter. Ooh, you don't say. Where? Here? Hmm. Okay, so one of the other pieces is bogus. This one. Down to 4. Good. Okay, so we want shard, DB name, checksum, and page count. Want transaction ID, followed by page checksum, number, and data. Hmm. Actually, I don't. I want page number before checksum and data. Page number, page data, page checksum. That seems like a more natural order. All right, and what function is this? Create database. So we're in the middle of creating a database for our tests. We get the checksum for it. We just read it off the drive. Boo. Don't we have this already? It's right there. Checksum DBs. DB checksum. Oh, self.checksum DBs. Get a database back. What? Get DB. Oh, returns an option. Fine. It must exist at this point. Let. Okay. That's there. Now we only have 5 errors left. All right. Sorry, my mind was wandering. Mm. All right, and we kind of figured that out. Okay, so now we're to the point where we can just do that. Let's make sure the tests pass. All of them. And this is the test that was failing before. We're trying to fix this. How about everything? I haven't run this in a while. It feels like I'm missing some tests. Cargo test, HTTP data plane? Why doesn't it do the workspace? It seemed like it did just the ones that I had previously done. Is this some new feature I don't know about? Hmm. 3 failed. Uh-oh. I'll have to come back and figure that out later. I wonder when I broke that. Hmm. Database does not exist. Downloading. Thanks. 253. All right. Not looking. Not looking. Focus, focus, focus. But it's strange that test here didn't run those tests. Unhappy path. Okay. All right. So we need to implement this. And kind of want this to be like its own thing. kind of want this to just be like a function call. Find and send database page. It could be off of archive. I need to break this down though. Page number U32. Transaction ID is a transaction ID. What shall it return? Some sort of result that returns error. Okay. Now, look for the transaction ID for the most, let's see, find the most recent transaction ID for the given page. And we might test this one in here. Range or range keys, though. For a range, let's just get one on there. Because now we do need the value. The values are not very big. But if we're having to search a lot, then maybe we stick with keys and then do one final lookup. Obviously, in the test case here, it's just not enough. Not enough data mutation. We'll probably have to create something that exercises that. Self.db.range keys. What does our range look like? It's going to be transaction ID. Shard, database name, DB page, transaction ID. But do we need a range? Like a... So this is the end transaction ID. This is the beginning transaction ID. If I could only type it. Epoch, salt, and change. Epoch. That's going to be end transaction ID. Dot epoch 0 and 0. Oops. Didn't fill out range. Need to do that. Can those actually be ranges? Did I... Wait, what did I do with this? Equal value. I did not implement. It needs to be 2vec on those. Out of curiosity, what does... Okay, into a bound range. From a bound. Okay. Key. What is a key? Okay. Vector. I was hoping there was some way to automatically go between the types. Maybe there was a trait I could use. Expected transaction ID. Oh. Yes, of course. So we have beginning and end transaction ID, but then we need the keys. End key uses end transaction ID. Beginning transaction ID. Beginning key. End key. Our limit is 10. I don't know. Okay. I'm thinking that we go with something very simple. We get the keys for a time range. So if somebody, the normal workflow that would happen here is that um, what is it? It's I'm sorry. Sorry. Two different thoughts. Yeah, had one of those light bulb moments. Um, Basically, the rain. Sorry. No, I'm skipping that. Where I was going to what I just thought of. Essentially, we're trying to scan this set here in hopes to find a transaction ID. Right? You know what? My idea is not going to work because transaction ID and page number. Basically, I was thinking that there would be some way to have a reverse search. Actually, why don't we do this with some sort of reverse? So the scan is just reversed. How would we do that? Basically, we need the transaction ID to be inverted. Can we just subtract from max? How interesting. Because that's all we ever want. We only ever want to be able to go through this data backwards from the order it was inserted in. So if we could change this, so we could still use, use it as transaction ID, but transaction ID became some other value that would order in a different way. And this would work really well. If we take max, use 64, subtract the epoch from it, then that would help them to order at least the highest level at the second level. I think that's what would happen, right? If we're trying to just need to verify this. Let's say max is 100, right? And we are currently at a time code of 33, right? And we're going to go to 34 and then to 35, right? So we start to say, okay, well, let's just subtract 33 from 100, whatever the max is. And then we have 77, right? 76, 75. That's not. So I'm having kind of one of those mental moments. 33, 77. That's not right because, I mean, oh, no, that is right because this one comes before these and this one comes before these. Oh, goodness. Okay. Nope. Everything just clicked. Okay. That does work. So we just subtract that value from max, and that gets us into a bucket, a bucket that's 1 second big. So we could look for all of the values in this one within that page, within that second. No, it wouldn't be within the second, but we would say from this inverted second up to some very large value, give me 1, and it would find the 1. Yes, yes. The plan is coming together. This just became much more efficient. Okay. Yes. I like it. Where are we going? That does mean that we need more changes. DB keys. No. Oh, transaction ID. That's right. So transaction ID, though, can we invert the other ones too? We can. Just do the same thing. Oh, function invert. What's the mathematic operation for this? I mean, we're subtracting it from max, right? But it's not really inverted. I'm gonna leave it for now. So in this case, we would have a new self, and this self would have epoch is U64. Oh, hold on a sec. Okay. 64 max minus self.epoch. Okay. Then we have salt. U32 max. Self. Self.salt. Okay. That's the inverted or reverse. Maybe we'll call that reverse. All right. Right. There you go. All right. Back to it. Reverse. Now we could write a little test to make sure that reversing it twice is the same as we started out. So why wouldn't we? Let's see. Test. Okay. 3 errors. We'll just leave that there. We'll run that later. Oh, let's click the little arrow. What happens? I couldn't compile. Not surprising. Okay. Find most recent page transaction. Arguments are incorrect. Shard name, number, transaction ID. Shard name, number, transaction ID. How are they wrong? Oh, stirs. Oh, no DB name in the scope. What is our database name? Just name? Yeah, it's just name. Okay. Okay. I feel like there's something that I've not gotten right. Oh. It's in the in context when we're creating a database and we set the page, set database page, right? When we're inserting here, This should be page checksum. When we're inserting here, I'd group those. Okay. We want to use the inverted transaction ID so that we can scan them more efficiently. That's it. Okay. That would have been a tricky one to go and figure out. Good. All right. Go back to replicate. Let's implement this. All right. This is where we started out just a bit ago. Well, we should probably document that this is reversed. Okay. Now this is completely different. Let's work from the bottom up here. So we want to scan. Right? We're scanning for this using a reversed key. And because we're doing that, we don't have to do anything crazy with it. We use the end transaction ID. We'll say that's just the transaction ID now. Database key. Let's get rid of the beginning ones. Going to have that dot dot. And we want one item. So we'll start with one key. We start with the key with an open-ended range. Just find me this and the one after it. We only want one. It needs to be reversed though, not reverse. Look at that. Okay. Oh, that is so much better. Find most recent page to transaction. Good. There are going to be so many fewer database hits because of this. Hey, give me one. Actually, we don't even have to do range keys anymore. We know that it'll return the right value. Okay. Now this we need to await. And once it's come back, we get a result with a error or a KV pair. All right, so let's map the error. No, let's do a with context. Storage snafu. Okay. It's got part of it. Toss that on there. Now we need the data, and the data will be our AV pair. It'll be a vector, but we only have one. Okay. Let KV pairs equal to that. We'll use self instead of elf. Yes. And our goal for this was to return the deserialized data. Okay. What data is that? What are our types? We want one of these. Transaction ID, key data. Is that everything we need though? Yeah, because we just need the new transaction ID. We'll pass back a new transaction ID. No, we want the page checksum. Well, that's right. So we need two things. We need a page checksum and a transaction ID sent back. Let's just tuple that. Page U32. Because if we don't do that, we have to come up with a name. And naming things is the hardest part of programming. Let's name something. What is this thing? So we end up getting, let's see, that stores the page checksum. Was it the page checksum? Let's see. Yeah. Page checksum and the transaction ID. This is checksum info. So we need to parse K to get the okay, we'll need that. We could put the actual transaction ID in the data, like the value portion, but why store it twice? I don't know. Why? Okay, parse the key. Oh, and this was checksum info. We only ever want the first one first. Let's match that. Because what if there isn't anything? Hmm. Feels like it should bubble up to like a range error. So maybe this is a option 2-1. We'll let the higher level deal with that. Okay, none. And value. I'll parse the key. What do we want for key? I need to know how long this is before that. Um, that's 16 bytes. Oh, we just want the last bit. Okay. Um, okay. So that's a deserialization snafu. We have our transaction ID, our found transaction ID. We want to return, okay, a sum, checksum info. And the value for that. I keep importing OS and into the files. I don't mean to. Transaction key data. All right, now we need to add some logging. Inspect error. All right. Log error. What is this? Find most recent page to transaction. Oh my goodness. Cannot deserialize transaction ID. And this is okay. Trait bound. Wait, for key? What is key? Oh, keys and vector view aids. Really? Did I? Oh, I redid it. Let's rename this one. Let's search key. All of these should be copy and clone. They're really shallow. Scan key. State key. Database info key. Okay. What else? What else? So as we're going through here, we do a search. We get the first element. Oh, this one is found reversed. We have to reverse it. Good. The data. I think that's it for this one. We no longer have to go searching with our quote unquote reverse binary method. We just find the first one. You'll find this happens also with things like AWS's DynamoDB or goodness, any large database like that on the cloud providers where you have to search for things using scans, ranges. Yeah, I think this will work really well. Okay. I feel like I want to test that on its own because then I can test just the searching, the finding of one element. And as long as everything else just behaves, then we don't have to go through and test at a higher level. I like that. So we would have to insert, let's see, a bunch of those. Want a context? A bit much, yeah. Okay. Find most recent page to transaction. Test. Tokyo test. All right. So let's insert. We need a database. So we need a tempter. We need sled. One of those. And now we need an archive server. That means something else, doesn't it? So we want an archive. Okay. Maybe it does mean that. Hmm. Is that right? RS test like that? Hmm. I didn't realize it repeated itself. Archive. Gives you an archive. Oh, missing generics. Okay, this one is storage sled storage. Really? Or maybe just sled archive? Okay, it's unused. Hmm. So before, we were just setting the page info here. I want to just do this piece. Let's see, is this all the info we need? Check some. Okay. Okay, all we care about is that it's saved. There's no data to parse. No, you are the future. Oh, interesting. Maybe we need a more generic get and put. I think we do. Sent. Then we'll take a key, right? And the key must implement something, some trait. We'll take a value. Value will also implement some trait. Just a moment. And I'm on cue, on mute. Great. Okay, so what I was saying is, what is the maximum that this could be? What is the maximum length? And is it possible for us to have basically a trait like this for elements like so? Because in the creation, we could copy this information out into some slice that some array of data. Some maximum, right? Whatever it is. And that's what I was trying to calculate at the moment. What would the maximum for these be? Transaction ID, this is 16 bytes. Page number, 4 bytes. And just the bits and bobs in here. Okay, which one's the longest? This one? Page data? Yeah. So page data would be 256 plus 2 plus, let's do the zeros at the end, plus 9 plus database name, 256, plus transaction ID, that's 16, plus page number 4, plus 1, 2, 3, 4, so 8 zeros. Wow, so it's fairly small. So the key could sit on the stack, just and then they can sit as referenced elements. I kind of like that. What would that look like? Let's play around with database scan key. So we have some data. We put the shard in there. Goodness, I've not played with arrays so much. This is interesting. Okay, what can we do with it? Can we write to it? No. Oh, as mutable pointer. Okay. We probably needed it to be mutable. Chunk, split, sort, sortable. Let's ask Copilot. Let's see. Let's do on the file we're in. Whatever. Assistant error. Oh, yeah. Well, I don't. No, not that. Oh, I have to choose the right one. Sure, that one. Empty prompts aren't allowed. Can you just redo the one? No. Array of bytes. No, I want to write it into. Not very helpful. Like in C, we would just mem copy this. Slice, copy from slice. Ooh, I like this. Copy all elements from string to self using memcopy. Oh, the length of source must be the same as self. Okay. Is there another copy? Clone. Fill with. Copy within. Swap with slice. My goodness. This API is massive. Align to. Has SIMD. No. Okay, going back up to the copy. The length of source must be the same as self. That's not what I want. Fill with. Standard mem functions. Discriminate forget. Copy. Experimental. Hmm. I, I could get if it was like unsafe. Like, basically want to take bytes from one array and put them in another array, or from a slice and into an array. Let's go look at array. IMAP. Tuple. Oh, I guess array could be more complicated types. I'm thinking like just, bytes. This is just an iterator. Oh, can we do a cursor? Cursor on top of a inner T, where T imples what? Where T, as ref U8? Really? But I want... Yeah, the cursor helps you read. I want to write. See, write. Oh, you can do it for immutable. Okay, okay. Let's try that. Because then we can write to it. Standard IO. How do you... Oh, impulse write. Flush and write, right? Writes a buffer into this writer, returning how many bytes were written. Write all. Okay. Shard. The cursor implements write, doesn't it? Or mutable U8s. For... Let's try something else. Let's say key dot as mute. Ah, here we go. Now we can import it. Great. Kind of like this. Kind of. All right, so the shard. Shard underscore state underscore. I don't think that will ever fail. Unless, of course, it's out of space. Disambiguate the method for candidate 1. We're not doing async here. Goodness. Do I have both imported? Ah, yes. Look at that. What if we just put that there for a moment? I really want to do that? Not really, but we'll do it. Centerdale, right all. Centerdale. Hey, Basepath, thank you for the follow. If we ever needed to, we could store ranges to be able to find that in this data. Okay, and then we need database state. Oh, we have to do this again. Now we have key. We do not need shard anymore. Oh, we want that information here. You can't copy a range? Really? I guess the indices might not support it. Okay, shard length. Now we have our shard length. Great. I think we can get rid of that. Let's get rid of that. Oh, and we need to keep track of the actual length. is the current position of this cursor. So after we write, let's say 5 bytes, it'll be 5, won't it? Because the first byte, it's 0 based. Isn't length normally usize? It is. Not use key because key was borrowed. Oh, it's mutably borrowed. Really? Here. And it's done there. Okay. Hmm. Oh. Yeah, it doesn't want U8s here. Got two. Escape ASCII. There we go. I don't really want to call toString on it though. Where is from raw parts? Did I miss it? Yeah. Hmm. Oh, it's nightly only. Result. Okay. Hmm. Why were we doing this? Oh, this. Hmm. Yes. Okay. So we were going to build an interface. That's right. For set and get. We wanted just kind of simple types. Hey, Robin Malfay. Malfay. And thank you for the follow. Let's see. AAB Denor. Ab Denor. Wondering whether or not I want to convert the rest of it like this. I don't know. Just going to writing into just an array. Because then we can just use the reference. We stop allocating vectors all over the place. Well, there's only what, 5 of these? 1, 2, 3, 4, 5, 6. 6, 1, 2, 3. Yeah, there's only 6. Let's change this to shard end. All right, off by 1 errors. We're going into the valley of off by 1 errors. Everyone ready? Oh, and let's implement DB key for this. Database scan key. Self-type key. I don't like key. I'd rather have like data. Let's rename that. I mean, that's so much easier like that because we did all the work up ahead. We might use this multiple times. And for our logging, we implement this. Just nice and quick. I like that stir from UTF-8. You can just give it a slice. Arguably, we could say it's unchecked because we already know it came from a stir. Whatever. This isn't one of those unsafe only projects. And okay. All right. Next, let's move this impl down. Next one, let's have data. U8, let's say it's 1024. How often? Okay. The liver. Honest question. As someone without strong opinion on the topic, how often someone asks why you're using light theme? Oh, um, it's because I was working outside on the laptop quite a bit this past summer and started using Zed. Zed doesn't have the dark theme that I would like to use. Um, so I just kind of left it in light theme. If Zed had a Challenger Deep theme, I would probably use it. But no Zed, not here or in the Zed repo, last I checked. I don't really care that much. Um, both work really well for me. And functionally, I'm still able to write code. So, yeah, no strong preference. It's just that I flipped over during the summer. I did look into using Challenger Deep with Zed because I'm also using Zed now, which is another change. Let's see, we need DB name. Name start. Hmm. We're using use sizes to index into um 16? Sure. Let's see. Will that work? I don't know. I'm just gonna putzing around at the moment. Length. Goodness. It's not gonna be that much. Trying to save a couple little bytes because we're using so much right there. No, no, I'm not. I'm just I don't care enough. Not about that. Rather not just okay, blah blah blah. There we go. Okay, back here. Shard goes away, DB name goes away. Copy them all into there. Get rid of that. Hmm. All right, let's copy forth our magic new builder. Okay, we've got a length, we've got our key. Let's rename this to data and rename the other one to data. Now we have data, data, data. We write the shard and get rid of some of that. All right, we need forbidden token. So we write everything. Then we have our forbidden token, database state, forbidden token. And DB name. Oh, interesting. There. Oh, we do not need forbidden token at the end of this one. That's right. But what we do need is a start and end for the database name. What did I call it? DB name start, DB name end. All because range has no copy. Oh, we actually need it here. Hmm. Let's just make these mutable. Hmm. Oh, no, we still need that. Okay, so at this point, DB name start is equal to cursor.position and length is equal to that. And technically with this one, we do not need database name end because that's the end. We have to set it. We don't. Okay, good. There we go. And this is, let's see, state with DB name. Is that the same as before? Rescan key. No, okay, that's the scanner. Okay. That's fine. I suspect I got something wrong here. Yeah, there's a forbidden token at the end. We did not include that. Or I didn't. Yeah, I used NeoVim, that's right. And then I use Helix, which I really like. And basically I'm back to an editor with Vim, mostly because I wanted to get used to using Copilot and these other things, which I used and I turned off. Maybe I should go back to Helix. Thank you for pointing this out. I will think on this. And again, thank you for the follow. We might see some Helix-based streams in the future. Because I've basically got a terminal with a split in it. tabs. Have to teach myself Helix all over again after my Vim refresher. Forget it. We'll just do it now. Oh, then I got to do like dark mode in these guys too. Mm, I like that one better. What else do we have? Oh, our whiteboard. Does this even have a dark mode? Draw. Settings. Interface. Use a dark icon in dark mode. Do I have to set something to dark mode? Oh, yes, that is still very bright. Okay. And what else? Oh, yes. A sprite. Well, that's easy. Select everything. Get our paint bucket. There we go. Just remember, this is all your fault. I kid. But here we are, dark mode. Ooh, it feels like home. Talking about Helix more than anything. Okay, shard. I might miss some things, like the little being able to see the diff on there. All right. Change current directory. Reset diff change. Yeah. Luckily, there are other tools for that in a terminal. Okay. So we were looking at this one. We fixed that. Database state key. Go to database info key. Symbol picker. There we go. Wow. To reteach myself. Open last picker. No, we want. I think it's just the symbol picker. Database scan key. Yeah, we want database state key. Okay. Ooh, yeah, I got Vim fingers on now. This is gonna take a bit. State underscore database name. To vec we no longer need. Oh my goodness, how do I do this? Wait, how do I highlight the lines and start the selection? Yeah, I do like Shift V in Vim. Um, there we go. MAF function. We do not need lifetimes. Oh, is it? Ah, it's X. Oh, how I've missed you. Was it Q? No, it's I don't know, whatever this is, comma. Okay. Simple shard. Oh, let's copy shard from the previous one. How do you delete a line in this? We'll have to figure that out. See, I have everything in like bright mode now. Firefox preferences. Dark. And theme. Hmm. Default. Oh, that's font. Extensions and themes. There. Dark. Enable. Oh. Okay. Where were we going? We were going for. I just want to see. Is GitHub in dark mode now? Oh, it is, because I have my browser in dark mode. Lovely. Okay. Oh, Helix. Key map. There we go. Delete a selection. Delete to start of line. Delete to end of line. How about delete the line I'm on? Okay. It's just D. Delete selection. So you just highlight and then hit D. So it's, what is it? XD. We want shard. This one. Okay, impulse shard. That's shard. It's our selections. Surround. Okay. What's that? And we want DB name. It's basically to the end. Hmm. How do I? So in Vim, I would CT bracket text objects, word, paragraph, key map, split selection. Okay, here we go. Select entire file. Current line, if already selected. Okay. Shrink, join. Keep selections matching a regex. That I don't use. I could see how it's useful. Alt K. View mode. Go to mode. So you start a selection, then you go someplace. Match mode. Go to matching bracket. Oh, bracket, okay. Right, well, the data at self dot db name start. Yeah, that should be db name. Oh, we need a bracket. Too many brackets. Hmm. Now this is a function call. Same with that. Doesn't need to be mutable. Oh, is that because we only set it once? Oh my goodness, I hardly ever do this. That's awesome. That is great. How do I want like multiple cursors and stuff. Surround cursor. That's cool. Okay, I like that. You can set it once. It stays immutable. Love it. Okay, with that value done. Now for the next one, db info key. It's basically the previous setup, just with a different namespace. Just gotta take that. Whoops. Select inside. It's a surrounding pair. Does that not work? Huh. This isn't database state. This is supposed to be database info. Okay. Let's double check. Shard info name. Shard info name. Good. Goes away. Boom, boom. Pretty good so far. Info. We have lifetimes here. Nope. Just hop it around a little bit. Let's see. Oh, there are no more errors in the file. Great. So that's two of them. A scan key. Okay. Database state key. We did that one. Database info key. We did. Database checksum. Did not do. Hmm. Nope. Not used to the select boundaries here anymore. And what are we writing? Shard forbidden token. Database checksum. What is database checksum? Hmm. Why isn't it bytes? Because no reason? Oh, forbidden token stir. I should not have changed. Deal with that later. Oh, and these are all static. Okay. Come on, Helix fingers. Find your way back. Yeah. Good. Do we need as bytes here anymore? Nope. Oh, emit stir. Don't. But now it's not the same thing. Like if I change one, I have to change it everywhere. Did I not go? Oh, GL. What's my perform code action? Huh. Why? Code action. Is this only in space mode? So I have to hit space first. Okay. Gives us that little little flicker. See on the right there? Boom, boom. Okay. I'll live with it. Hmm. Hmm. Database state. Mismatch types expected. That is a slice of U8s. Found reference. Oh, for the right, it wants that as a reference. Oh, it is a stir. Oh, I'm changing the wrong one. That stays there. This one changes. There we go. What are we doing here? We're missing stuff. Going to get rid of all of them real quick. Okay. If checksum is ever used. Checksum. Database name followed by forbidden tokens. And we need a DB name end equals. I believe that's correct. Let's just make sure. Checksum token, checksum. Okay. Good. I think we can get rid of this. One more check. Checksum, no forbidden tokens after that. We didn't write the checksum. Right. These are big Indian bytes. Interesting. What is this? Yeah. Where is standard IO write? Standard IO write, write all, write UA. Oh, it's on cursor. Because cursor implements write for this. And write. Where is write U8 coming from? This is in Tokyo. Async write ext. That's not what I wanted. Let's just do that. Right. Okay, let's get rid of where that's coming from. Where's Tokyo? Do I need this in here? I don't think I do. We'll find out. Import standard IO cursor. Great. Can we just do cursor.write all now? We'll have to import that trait. I would prefer that. That. We'll just use write all over and over again. Oh, it only wants U8s. Oh, we don't want to do that twice, just once. Okay. That's better. I like that better. That's better. Core standard. What? Would rather it explode than fail silently. So we'll unwrap those. Unwrap, unwrap. Good. From UTF-8 checked. Okay. Database state key. Serialize. Database info key. A bit of the same thing. Ah, okay, so we have database info, shard name. Let's add a namespace. Function name. Why am I doing that? It's database info. Database checksum key. Okay, we have start end. Shard end. Database name start. Database name end. The data, the length, and checksum. And I don't think that we did this correctly. Oh, that's right. Okay, well, let's get the... Wonder why it's grumpy about that. Oh, it's not. All right, so we do shard token or shard forbidden checksum, db name forbidden, db name start, db name end, and then the actual bytes. db checksum dot 2 APE bytes. Oh, we could just take a reference to that. Let's add some spacing, make it a little easier to read. Good. Okay, that goes away. Let's grab some utility functions because we'll need them. Okay, 1, 2, 3. Got it. All right, so we have 1, 2, 2 more. Almost there. It'll be interesting to see how this sets up. All right. Four things this time. Gonna grab the previous one because I'm in a rush. Shard, good. DB name, start and end. Page. Page checksum. Oh, that was already there. Okay. Transaction ID. You can keep that as well. It's cheap. Let's go grab. Let's grab the new function. What's there? There we go. There you go. Hmm. Checksum goes away. EXN ID. Okay. Over namespace, which is transaction ID. The name. Let's double check. Shard, transaction ID, name. We want page and transaction. Name is there. I want page. Oh, hey, give me a couple minutes. More water. Okay. Ooh. TJ Delirium, thank you for the follow. 17 minutes ago. Man, I gotta get better at that. Excuse me. So we have the shard. How do I do a comment here? Toggle comment? Really? See, changes it. It lies. Oh, space mode. Got it. There it is. So we did that one, did this one. Transaction ID, let's check that one. Shard. Transaction ID, got it. And that. DB name. Yes. Plus a separator. All right, still off the DB page. Name. What was that? How did I do that? No way you can do that? Okay, that's awesome. We have our checksum done. And now we need forbidden tokens. Transaction ID. That doesn't work like that. Transaction ID. Here, we just need a reference. But our transaction ID. I have missed this search. We're doing this over and over and over again. We could do the same thing. We could store it just as an array. Why not? Why not? Because then we could convert when we need to, as opposed to always. Hmm. Do I have some AI thing going on here? Seems to have some recognition of what I want. That does not work. Yeah, something's kind of going on. 0. Let's see, 16. Okay. Now we need these guys here. Stuff like that. So we have our cursor. What is the info thing on here? Oh, space. I don't want diagnostic. I want show docs. Okay, space K. Does that not exist here? Too many errors. Yeah. Oh, and that. Okay. What do we have here? We have that return, why don't we just pass that in? That's it. Did I call 2 BE bytes on that? Somewhere. Must have. Okay. So we have that. 2 vector. Bye-bye. Ah, now the reverse. How about, since we no longer have self, we need to get to each one of those. Hmm. Expected. Hmm. Wow. Okay. I've been using a lot more unwrap with these arrays. I'm not sure how I feel about that. Is this something I should be doing? Is it good, bad? I don't know. Solve one. I change. Right. Maybe we should have little functions for that. Function epoch self. Exciting. Okay. Still haven't gotten to this point yet. Let's go back to the other file. Man, it feels like Helix is just, I'm starting to hit the keys again. Hands are just doing it, you know. All right. Let's go to the end of the file because, well, I know I hadn't gone that far. Okay, did we get, that's right, we were on transaction ID. Because we were trying to do a 2 big-endian bytes on it. What do we want to do? We want to write all transaction ID dot as bytes, something like that. Self.data. Done. Okay. Now we have transaction ID. It is there. Lovely. Save the cursor. Delete this function. All right. Let's go grab some utility functions from above. Self.namespace. Oops. What did I do? Now, namespace isn't correct. Should be using database transaction ID. Oh, it's usize. Okay. One more. Database page data key. Very similar to the last one. Some things are subtly out of order, though, so we need to be careful. I'm not going to keep. Oh, hey, let's go grab the other bits. Page name shard. Okay. Database page data. So this is page data. And it should be database name, transaction ID, and page. Page, transaction name. Okay, did we get the comment right in the previous one? Database name, checksum. No, that's not right. Should be transaction ID, short transaction ID, database name, page, transaction ID. Okay. Oh, two selves. That's not going to work. Comment these out like before. Shard. Shard. Nil. Transaction ID. Shard. Nil. Database page data. Yes, yes, yes. Okay, so we have two. Database page data. Nil. Name. Those three. Token. Transaction ID. Okay. Oh, we need transaction ID here. Name. Oops, nil. Transaction ID. Is that it? Oh, and then the page. No double nil at the end. Okay. Database page. Name. Shard page name. Okay. Transaction ID and page. Good. All right. It's not quite right though. Grab the utility functions. Okay. Shard name, namespace page. Just like the previous one, but the namespace is different. It's transaction ID. So previous one is, uh-oh, also transaction ID. That's not right. This one should be page data. All right. No errors in the file. Let's go top to bottom. Let's just look at the code, do a little code review. All right. Have a new import. Change these to bytes. Slices of U8s. Database scan key. Okay. Oh, and we need to import DB key for everything. So database scan key does use database state. We do have the final bits there. Okay, database state. Database state. Good, good. Okay. Scan key, same as before. Okay, good. It's using the previous functions. We imported DB key for it. This is going to be like the same on all of them. Okay. Database state key. State, good. State, good. This log. We did not import that yet. We'll come back and do the import for everything. Database info key. Database info. Namespace, database name. Okay. Database info, database info. Good. Checksum. Checksum, database name, and checksum. Transaction ID. Transaction ID. Transaction ID. Got it. Good. Trying to end each one of these with the write all of the forbidden data. Already checked that. That's good. Database page data key. Database page data key. Looks good. Let's go grab the impl, toss it on everything. Wherever it is. Itty bitty little impl. There it is. All right. Database state key. Database info key. Checksum key. Database transaction ID key. And page data key. Okay. Hmm. We're going to test. I don't know. Data archive. Good. Lots of things wrong. Try join. Interesting. Yes, we were working on set and get. And this is GJ1118. Nope, this is the same machine. It's all in the same machine. Good question. We'll do this. Where? That's a DB key. What was on this? DB key. Okay. Hmm. Maybe that should be something else. Anyhow. Not sure yet. Do something with that. It's something that can be serialized here. Okay, so we want this so that we match. Do one of those. Get rid of that. Instead of removing the sound, maybe sized bound to make this parameter sized. Does it need to be sized? Uh, we need the reference. That makes sense with this maybe size then. Okay. It might not live long enough. Really? Why? I thought this just wanted a reference. Oh, what did I do? I said that it needed to be send, sync, and static. This reference. That should be okay. Oh, I don't want that. I want here TiKV. What? You're welcome for the information, GJ1118. See, we have this behind our own little interface. So we have our trait that kind of abstracts this. Russ, thank you for the follow. If you're still there, man, 38 minutes ago. Did I already say that? All right. Well, and we do this because it ends up going into the future, which is returned here. And we can't limit the lifetime of a future. How do we do a lifetime annotation for that? I feel like I was steered in the wrong direction. Right, when this was async function, right, and it just returned that, it was giving me some hint to change it to this. I don't remember what that was though. Let's see, let's do some searching. Rust trait return future with lifetime. It's 2023. December 21st, 2023. A lot has changed since then. Arguably, we would only have to look at the announcements. Once. Let's go look at that December one. Where the gaps lie. Yeah, so this is what happened to me. The infiltrate, which is basically what async function is doing, right? The reason that users can't put additional bounds on the return type, for example, there's no way to write this function in a way that is generic over container trait. Otherwise, you should consider using an associated type. Okay, that's number one. Async function in public traits. Since async function desugars to that, same limitation applies. Of particular interest, async users are send bound. Creates two versions of your trait. Dynamic dispatch, okay. Under non-send, that's fine. Hmm. Yes, why don't they? My headset just died. Okay. Trait and associated type is stabilized. Note that. The return type is already assumed to capture input lifetimes. What input lifetimes do we have? Self, key. Hmm. What if we change this? How do we change it? Let's say, what if we give a concrete type here? Let's say something like that. type and trait. Oh, that's referenced somewhere. And we do not need key. Okay. V, one type parameter. Sled storage. I want to go as far as possible before it gets converted. TiKV is really the culprit, though. So at this point, it needs to be to implement into a key, and that I believe is an owned thing. Does that make this type unknown? Yeah. I want to see. Let's look at where key is. Trait implementations from a borrowed vector. It's pretty much just owned. Hmm. I think I would rather just allocate to send it over. I, Did that put change not cause any errors? So here, put, I changed it so that it now has basically this lifetime here that's deleted. It's okay. Fascinating. Maybe once all the other errors are clear, we'll have something. All right, let's do some house cleaning. Set database state. Hmm. Self output. Key value. Really? What was that put on? This is archive, is it not? Yeah, this is archive. Oh, it's called set. I could call it put. Did not do get. Self.db.get. Hmm. Let's toss a get up there. Sorry, not very chatty at the moment, but it's saying that he does not live long enough. Move out of key occurs here. Where is that? Data archive. Okay, it's around here somewhere. Ah, here. Lifetimes. Parameter K does not live long enough. Line 129. Yes. Consider adding an explicit lifetime bound. I don't want to. Here's more info. Cannot move out of key because it's borrowed. Move out of key occurs here. Oh, really? You could clone it if it's an error. Why do we have to do that though? So it's moved here and it's borrowed here. Is it because we're crossing awaits? He dropped here while still borrowed. Go to borrow key. Okay, that's better, but this here, show me more. Lifetime A defined here. Borrowed value does not live long enough. Oh, this value. Oh, is that? It's data. That's just vector view weights. Here, we're borrowing it. Now this needs to be deserialized owned. So the value here is limited. Getting closer. Rename that as DB key. Let's rename this here. I think this should be barred as well. Eugene, how you doing? There is a Rustations team on Twitch. It's been around for 4 years, maybe longer. I don't quite believe it. Let's say set key. Okay, that's not too bad. Get database state. Self dot. Info. So I made some changes to clean this up, and as you can see, I'm deleting quite a few lines of code. Um, Get database info. And now this one is a little bit more complicated. Get database info at checksum. Hmm. I think maybe we are logging. Set. We need some of the inspector. Same here. I think I want a stronger association between what the key and the value are. So let's see, for DB key, can we have a type? Um, value type. And we could say value type must implement serialize and is serialize owned. What I do? Because if we had that, and we went back, then here we could ensure that when something is being serialized, it was being serialized to a specific value. Serialize. So how would I create that association between the two here? Basically, what I want is like V is K value, something like that. DJ Spears, how's it going? What if? I'm all right. The stream's running a little long. I'm starting to wear down. Value here. I want to be able to set or specify this value type is that other thing. Something. Oh, it didn't complain too hard. I think we have to specify V now because we have K, wherever K is on the keyboard, value type, and it must be deserialized zoned. Okay. Why do we even? Oh, this should be copy. This should be copy. Well, I think my time is up today. We've gone for 7 hours. So I'm going to call it. And believe it or not, I'm going to go open a jar of pickles. So let's figure out who we're going to. Who's streaming Rust? Krampus hack. Oh, that sounds fun. All right. So till next time, take care, y'all. Bye bye.